here is another scenario in which we can use fraction arithmetic to model the probability of this situation. It's a little more complex, so stick with me. In this situation, we have a game, and we have a duck pond and a frog pond, as I have shown here in the diagram. So our duck pond and our frog pond have ducks and frogs floating in them, little toy ducks and frogs, and some of them have X's on them, and some of them have O's on them. You can't see them when you're picking the frog. Have you ever played this game at a fair where they have all the ducks floating in the little pond and you try to pick one up and you try to get matching colors or matching numbers or something like that? And that's what we're trying to do here. So for this game, in order to win the game, we need to have either a duck with an X and a frog with an X, or we need to have a duck with an O and a frog with an O. So we need to have both the duck and the frog to have the same letter. All right. This is an independent event because our duck pond and our frog ponds, they are separate. And so they don't overlap. We don't have the chance of picking a frog first. We are just going to pick a duck and a frog with the same letter. All right. So we have down here, I have a diagram. This is taken out of your book if you want to look at it in your book. We have this rectangle, and the rectangle represents playing the game many times. And so first, we have the probability of drawing a duck that is marked with an X. So we have divided the rectangle into 5 pieces representing the 5 little ducks on the pond, and one of them is colored in. This represents the 1 duck with an X. So we have 1 out of 5 chance of picking a duck with an X. Now, because we're eventually, so we have a 1 in 5 chance of picking a duck with an X, we also want to look at the ducks marked O, right? Because we could pick a duck with an O and then a frog with an O. So we have here a 4 out of 5 chance of picking a duck with an O. All right, we've talked about the ducks. Now we have to talk about the frogs. All right, so once we draw a duck, we have to draw a frog. So we're going to divide our box into 4 even slices to represent picking the frog out of the pond. All right, so if we pick a duck with an X, the colored in part here, we also want to pick a frog with an X. So 3 of these little pieces here represent picking the frog out of the pond that has an X. So 3 out of 4 times we are going to also pick a frog with an X. Great. Success, we win the game. Now, what if we don't pick a duck with an X, we pick a duck with an O? Now we can color in these 4 spots at the top that represent for every, we have a 1 in 4 chance of picking the duck with an O and a frog with an O. So we have a 1 in 4 chance of picking a frog with an O. All right, so now we have to calculate our probabilities the same way we did before. We're going to multiply our fractions, and we see here that we have 3 out of all these boxes, 3 out of 20 times we could pick a duck with an X and a frog with an X. And 4 out of all these chances, 4 out of 20, that we could pick a duck marked with an O and a frog marked with an O. And then because chances, to win the game, we could do either one of these. We could do either duck with an X, frog with an X, or duck with an O, frog with an O. We want to add these 2 probabilities together. So instead of multiplying, now we're adding, and we get 7 out of 20 chances of winning our game. So hopefully this helps you to understand using fraction addition and multiplication, and symbolizing the fraction addition and multiplication, how this impacts our probabilities. Hope it helps.